or just understand exactly what we're dealing with. So we're looking at the velocity graph. Again, we have our velocity is negative, and then we have our velocity positive. And so what they're trying to say is, he does our v sub t. If it's at rest, that means v sub t has to equal 0. Well, to go from a negative velocity to a positive velocity, guys, I don't care how you do it, we have to eventually have a point where v sub t is equal to 0, right? So we have a continuous function, and we have a closed interval from 0 to 8. So as long as we have a continuous function and a closed interval, we can use the IVT. And to show the IVT, we just want to show that there is a point below v sub t is 0. So I will write this. Particle at rest is v sub t equal to 0. So all we need to do is show that there's a value where v sub t is less than 0, and show that there's a value where v sub t is greater than 0. But I'll start off by showing my conditions for using the IVT. So since v sub t is a continuous function, on a closed interval, zero, 8, and since we have a value below, so we could say that, how did I write this? So we could say, it doesn't matter which one you choose. You could say v sub 2 is less than 0, and v sub 5 is greater than 0, then by the IVT, we can just say now there must be a time interval where the particle is at rest. So you could say a time, or you could say where t is enclosed on the interval 0 to 8, where the particle is at rest, or v sub t is equal to 0. And you could say either one or the or. OK?